Day 5 homework, page 120, number 24. This one is difficult in the sense that it's three-dimensional, so the diagram is a little bit difficult maybe to deal with. But it's easy in the sense that there's a lot of symmetry. All three forces are 200 newtons. We're trying to figure out the force at that top point on this particular tower. They call it a mast. And the other information they taught us in this problem is that the mast, the tower, is 20 meters tall. I'll just put that in here, 20 meters. Really, and this problem goes kind of fast once you see this, each vector, force, tension, is 200 newtons, and they're actually at 45-degree angles with respect to the mast, because they're 20 meters from the bottom of the mast, and the mast is 20 meters tall, so that is a 45-degree angle, and it's 200 newtons. Okay, so that force is 200 newtons, each one. And each of those ropes that those people are pulling on have components, a downward component towards the ground and an outward component. You can call that T, let's call that T sub y and T sub x. But it's the same for all three people. And it's a 45-degree angle. So once again, you can use the shortcuts for 45, 45, 90s. Just divide by root 2. So Tx and Ty are both going to be equal to, if you take the 200 divided by root 2, 141 newtons. And T sub y is 141 newtons. But if you look at this problem, if you were at the very top, looking down at the mast, the mast would look like a point with the three people on the outer spots, like 120 degrees separation. Bottom line is the x component would all be in these directions, but because of symmetry, each of those forces is 141 newtons. Radial outward, if we're looking from, like, bird's eye view, all three of those forces will cancel. The x components will cancel. So all you are left with is really the y components, and there's three of them, so basically the answer is just going to be 141 times 3. That is the answer. So 523 newtons of downward force on that mast.